we factor first. And I haven't even looked at it, but I'm going to guess that one of those might be an x minus 5. Just thinking about it. Let's see. Does it work out? 35. Could it be possible that a factor of 35 is 5? So it's going to be 5 and 7. I'm going to guess the minus is there already, that it matches up. And then this would be minus to get the plus 35. Always check. Does it actually FOIL that out? Does it actually equal x squared minus 12x plus 35? Yes, it does. And here's another example where if you went directly to cross multiplying, you'd run into problems. Because you would get an x cubed again, and that would be a big issue. All we need to get a common denominator is another x minus 7 on this side. And now that I have a common denominator, if I wanted to multiply both sides by x minus 5, x minus 7, that would cancel out these. And I'm left with minus 10 x squared minus 7x. I might show this one with the other technique as well, where you just multiply to get rid of fractions, if you've been liking that one better. But here we've got an x squared again. How do we solve x squared equations? Make one side equal to 0. Factor x minus 5 minus 2. So x equals 5 and x equals 2 are the two answers that we get. We check our non-permissible values. X can't equal, go to the original equation, 7 and 5. Ooh. One of them is extraneous, and only x equals 2. Because 2 isn't a boom value. Okay, I did this question first by getting the common denominator and then multiplying both sides to get rid of that. I'm going to do this question, just start it in the other way. Because this is the other way is more typical of what we did when we add numbers as fractions, multiplying to get rid of fractions. So again, you would start by factoring. And we already know that this is x minus 5, x minus 7 equals x over x minus 5. Now, if I wanted to get rid of this fraction, x minus 5, x minus 7, I would multiply both sides by x minus 5, x minus 7. X minus 5, x minus 7. Here, the x minus 5s would cancel, the x minus 7s would cancel. Here, the x minus 5s would cancel. And it gives us exactly the same thing that we had in the other question. So notice the difference between the two techniques to start. One is get a common denominator, then multiply both sides, which will cancel out the denominators completely. And the second way is just get rid of fractions by multiplying at the beginning, and it will work out exactly the same. All right, part B. Again, start off by factoring, and that sometimes means you just have to rewrite a bunch of stuff. The interesting thing about rewriting the math is it takes about as much time to rewrite as it does to sigh and complain that you have to rewrite it. So if you're like, oh, I have to rewrite it, by the time you do that, you could have actually rewritten it in that amount of time. So just, I recommend not sighing and rewriting. It's not worth it. Here we have an x plus 4 and an x plus 6. Surprise, surprise, that the other side had an x plus 4 and x plus 6. If group those together, Which technique do you want to use in this one? The multiply technique or the common denominator technique? The common denominator one? Okay. So here, this one's missing an x plus 4. This one is missing an x plus 6. Now that all of our denominators are the same, if you would multiply both sides by x plus 4, x plus 6, all of these will go away. Here we're going to have to FOIL. That first one you're going to get x squared plus 5x plus 4. I'll keep it in brackets for now. Plus, here you'd have to FOIL x squared plus 4x minus 12. And here on this side we would just be left with 11x plus 32. So all that practice foiling and distributing comes back in these questions because now you hopefully can do it faster than you used to and can just hopefully write it out in one step. If you still need to do 2 steps where you draw the arrows and do all of that, that's fine. I have x squared. I'm going to combine my like terms on this side first. I'm going to get 2x squareds plus 9x minus 8 equals 11x plus 32. You recognize that since you have an x squared, we need to make one side equal to 0. Move the 11 over. And we have to factor. Now I see that there's a 2 in common. I can factor out the 2. Some people like to divide both sides by 2 instead of factoring it out. That does the same thing. But I'll just factor it out for now. Has to be x and x, 20, 5 and 4, 5 negative, the 4 positive, so x is equal to 5 and x is equal to negative 4. What are our non-permissible values? Go back to our original equation when we factored negative 4 and negative 6. And, oh, boom, got an extraneous root. So x equals 5 is the only answer. And for practice, you can do 9 and 10.